Within our retina, we have our two photoreceptor cells, and this is called cones and rods. Our cones can be found both in our macula and our fovea, and the rods are only found in our macula. Our fovea only has cones. So cones has three functions. Number one is color vision. When I think about color vision, I think about the fact that cone starts with the letters CO and color vision starts with CO. And then it also deals with high acuity. So cones are densely packed in the fovea, and because of that, they're able to make our vision very sharp. Since there's so much density, there's high density of cones, it allows for high visual acuity, which is just being able to see clearly, and enables us to see the very fine details and distinguish between objects with precision. So we're able to look at what is the difference between one plant's leaves and the other. Next is daylight vision. Since cones are sensitive to three different specific colors, these colors can be seen in the daylight. So cones have to do with seeing throughout the day. Rods, however, are for night vision. Rods are specialized for low light condition and are responsible for ability to see in the dark, in the dim light, so at night. And unlike cones, rods are not involved in color vision. They provide us with grayscale vision in low light environments. Rods has to do also with peripheral vision. Since the rods are primarily located in the peripheral region of the retina, which is away from the fovea, and I said a while ago, the fovea only has cones in it, they contribute to peripheral vision rather than our central high acuity vision. And another thing is rods is great for motion detection. Rods are highly sensitive to motion, and they make it crucial for detecting movement in our surroundings, especially when it's dark. Because when it's dark, it makes it even harder, right, to detect motion. But thankfully, with rods, we are still able to. So I've used Squid Games as my analogy for a lot of this. So, for example, for rods, if you watch Squid Games, you know that the doll in Squid Games is detecting motion of the players, if they're walking, if they're not walking. And dolls are made out of rods. So I think about, since dolls are made out of rods, they're able to detect motion. And a while ago, I mentioned that cones is sensitive to three specific colors, three different range of wavelengths. The three are short cones, medium cones, and we have long cones. Each of them are sensitive to a specific color. Short cones is sensitive to blue light, medium cones is sensitive to green light, and long cones are sensitive to red light. Now, how do I remember this? Using Squid Games, one of my favorite shows ever. So when I think about the fact that short cones is sensitive to blue light, I think about how short cones, short, the word short, in Squid Games, once again, with that green light, red light game with the doll, the people compared to the doll, they're very short because doll is huge. The people that are playing, the players, they're short. And what color is their uniform? What color are they wearing? They're wearing a blue uniform. Now, that reminds me that short cones are for blue light because the short people in Squid Games are wearing blue. Next, medium cones are sensitive to green light. Now, for medium cones, green light, when there's a green light, it means that the players are able to walk or they're able to run. But the thing about the game is if you pace yourself, you're more likely to win because it'll be easy for you to stop. So they have to do a medium walk. Okay, they have to do a medium walk right in between that running, right in between the walking at the same time. So when it's green, the players have to do a medium walk. And long cones, lastly, are sensitive to longer wavelengths associated with red light. Now, long, and red light. When there's a red light in Squid Games, there's a very long stop. In that long stop, that's when the doll starts looking around and trying to detect if anyone's moving or not, right? But she does that using a long stop. It's not a fast stop, it's a long stop. So when there's a long stop, it's because there's a red light